Welcome back, everyone, to our Intro to Trigonometry. So, we're going to continue our work with identifying our trig functions. Remember, SOHCAHTOA to help us identify our three basic, and then we just flip them for the reciprocals. But before we do that, you may need to find the third side of a right triangle. So to do this, you need to remember the Pythagorean Theorem. So we use the Pythagorean Theorem to find the missing side of a right triangle. A squared plus b squared equals c squared. Remember, a and b are just our legs, and c is our hypotenuse. So, I'm sure you guys all remember Pythagorean Theorem, but it is something that we needed to refresh ourselves with. So here, find the values of the given trig function. They want us to find cosecant of theta, which, if we recall, cosecant is the flip of sine, so we need hypotenuse over opposite. So let's look at the triangle that they give us. Here is theta. Here is our given angle. We have the hypotenuse. So that is something that we have. So this is going to be 12. But if we look, we do not have the opposite. So we need to find what that is using the Pythagorean Theorem. So we need to find the opposite. So our legs, I'm just going to call the opposite x. So that way we have a variable. So x squared plus 9 squared is equal to 12 squared. So x squared plus 81 is equal to 144. Subtract 81 from both sides. Give me one moment. Yes, I need to use a calculator. Can't do it right in my head. So we have So we have 63. So x squared is equal to 63. Then we take the square root, and we have x is equal to the square root of 63. So that is our opposite. Yes, I want you to leave it as a square root. Do not write it as a decimal. So in our bottom here, the square root of 63. Now, we'll come back to this. There is something that we still need to do, but we'll talk about it later in the notes. So put a pin in this. We will finish this problem here in just a moment. All right, next. If A is 4, so that is a leg, and C is 6, which is the hypotenuse, and angle C is the right triangle, find sine of A. So angle A is our given angle. So I'm going to label this A. C is our right angle. So we want to find sine, which is opposite over the hypotenuse. They say that the hypotenuse is 6, and little a is always opposite angle A, so that is 4. Oh, this is nice. We needed our opposite, which we have, and the hypotenuse. So we do not have to use the Pythagorean Theorem here. So this is going to be 4 over 6, and that can simplify. So sine of A is equal to 2/3. All right. So next, find the values of the 5 remaining trig functions given that cotangent of theta is equal to 4/3. So first, lay down where you want theta to go. It doesn't matter where you put theta. I like to put it on the triangle that already has our little sine. But once you plop down theta, we're going to write, this is our hypotenuse, this is our opposite, this is our adjacent. Now, they tell us what cotangent is. So I'm going to just write sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta, they already told us, is 4/3. So we need to find all the other 5. Well, what's nice is tangent we can get done right away. Tangent is we just flip cotangent back, because cotangent is the flip of tangent. So this is going to be 3/4. We now need to find the others. Well, let's fill in our right triangle. Tangent is opposite over adjacent. So my opposite side is 3. My adjacent side is 4. We now need to find the hypotenuse. And to do this, to find our hypotenuse, we're going to use the Pythagorean Theorem. So, 4 squared plus 3 squared is equal to x squared. I just use x for the side of the right triangle that I'm finding. It doesn't matter if it's a leg or a hypotenuse. So we have 4 squared is 16, plus 9 is equal to x squared. 25 is equal to x squared. Take the square root, and we get 5 is x, which is our hypotenuse. So now we have our hypotenuse. It is 5. So now we can find the rest of our trig functions. So sine is opposite over hypotenuse. So our opposite is 3, and our hypotenuse is 5. And then for cosecant, flip it, 5/3. Cosine is adjacent, which is 4, over hypotenuse, which is 5. And then for secant, flip it, 5/4. All right. So now we're going to talk about that pesky square root up here that we had, square root of 63. Because technically, we cannot have a square root in the bottom of our fraction. It is not fully simplified. So we have to do what we call rationalize a denominator. For a fraction to be fully simplified, there should be no square roots in the denominator. When there is a square root in the bottom of a fraction, you must multiply the top and the bottom by the square root. So before we do this example, let's go back up top to this one and fix our answer. So we need to rationalize it. So multiply the top and bottom by the square root. Now what's going to happen is the top of our fraction is just going to be 12√63, but the bottom, the square roots will cancel, and it's just going to be a 63. So there we go. So that is what we do when we rationalize a denominator. So now that we have this one taken care of, let's do this problem. We have tangent of theta is the square root of 17/8. Write the remaining 5 trigonometric ratios for the given angle. So here's theta. So we know that this is the hypotenuse, this is opposite, this is adjacent. So we have sine theta, cosine theta, tangent theta, and then we have cosecant theta, secant theta, and cotangent theta. So let's start with what we already know. Tangent theta is √17/8. So we know that already. So we can find cotangent. It is just the flip. So 8 over radical 17. Now, as you can see, we have a square root in the denominator. We're going to simplify all of them last. So we'll simplify this at the end. Let's find out what our triangle is. So tangent is opposite over adjacent. So the opposite is root 17. The adjacent is 8. So we need to find our hypotenuse. So the square root of 17 squared plus 8 squared is equal to x squared. So we have 17 plus 64 is equal to x squared. 17 plus 64. So we have 81 is equal to x squared. Take the square root, and we get 9 is our hypotenuse. So now it's time to find the rest of our trig signs. So sine theta, opposite, which is root 17, over the hypotenuse, which is 9. So now flip it, 9 over square root 17. Again, we will fix this at the end. Cosine is adjacent, which is 8, over the hypotenuse, which is 9. And then secant is the flip, 9 over 8. Awesome, we don't have to fix secant. But now that we found all 6, we do now need to fix the square roots in the bottoms for cosecant and cotangent. For cosecant, multiply top and bottom by root 17. So cosecant is going to be 9 root 17 all over 17. And now do the same for cotangent. Multiply top and bottom by radical 17. So we get 8 square root 17 all over 17. And there you go. The big thing is no square roots in the bottoms. And that's our intro to trig. We're going to be doing a lot more trig stuff in these next coming weeks, so stay tuned.